Hello, everyone. In this video, I'm going to look at two examples of solving log equations with some properties of logs, or I should say utilizing properties of logs. The ones in particular I'm going to look at are the properties that are. I'm going to look at the property of if I have log base b of x equal to another log with the same base, I can effectively get rid of the logs and I'm left with x equals y. In other words, if you have a log on each side of the equation, then you can effectively just cancel the logs out. Now, as I cancel in kind of a loose sense, you're not actually canceling anything. You're actually applying a definition. The effect is something like canceling, though. I don't want anyone to think I'm actually canceling anything out. And then the other one I'm going to apply later is the reverse of the power rule. Power rule says that if I have log base b of some x to some, I'll just say c as an exponent, I could bring the c in front of the log, just like so. For example, let's look at, and as always with these, as you might imagine, the question is going to say solve. Let's say I have a question, something like log base 7 of x squared minus 30 minus log same base of x equals 0. Now, what's notable about this equation, if you've seen it, some of my other videos on this process, I've said that you want to either, as you can see in my numbers here, you want to make sure all your logs are on one side with a constant on the other. That is true unless you have the situation that I have here, where I have my constant, I should say, 0, not like any other number. So it's not like it's equal to 2 or 4 or something like that. The difference here is, and this is where this part here, or one log on each side. If I do that, if that's the case, what I can do, what I'm going to do now is I'm going to move this log to the other side. I'm going to add it. Because now I'm going to have log base 7 of x squared minus 30 equals log base 7 of x, just like this. Now, if you're wondering, well, would you apply another rule like the subtraction rule since you have subtraction in that log? And the answer is no. If you're thinking that, you're thinking about the division rule, which is something of the reverse. You make a division if you start out with a fraction inside a log. For my log on the left, there is no rule for that. But the equation being what it is now, since I have log base 7 on the left side, log base 7 on the right side, as I mentioned before, I can effectively get rid of them. So I'm now left with x squared minus 30 equals equals x. There we go. Now, what I want to do is, since I have a quadratic, let me get all my terms on one side. So I'm going to move my x back to the other side by subtracting it. I'm going to go over here to give myself some more room. So I have x squared minus x minus 30 equals 0. And I can solve this as a quadratic however I'd like. It could be a quadratic formula. It could be completing the square. Or as I'm going to do, I'm going to factor it. Seems to be the most direct way. Remember, I need something that can multiply to a 30 and combine to get a negative 1. So that's going to be a 6 and a 5, specifically a negative 6 and a positive 5. And if you recall your zero product property, we'll say x minus 6 equals 0, x plus 5 equals 0. Solving each one gives me x equals 6 and negative 5. So I've solved it, but what I want to do now, this last step, since I did apply the rule of logs, now the change form that I mentioned here, step 3, that's what I did in, let me mark right here. This step is my way of phrasing it. I changed the form, so I went from 2 logs, and they effectively changed to this x squared minus 30 equals x. Now I'll solve, which I've done, and I need to check against the domain. So if you recall, for any log, the domain is x is greater than 0. So what I'm going to do is look at each of my logs, and they are here and here. These are my 2 distinct logs. Since the domain, meaning whatever you're taking the log of, has to be greater than 0, what I'm going to do is off to the side here, I'm going to test this out. I'm going to say that means x squared minus 30 has to be greater than 0, and x has to be greater than 0. And that's this x that I'm referring to right now. And now I want to solve each one. Now, here, my first one, I'll add 30 to both sides. X squared is greater than 30. And I can take the square root of each side. Oops. So I have, sorry for my writing. Let me try to make that more clear. So x is greater than or equal to plus or minus the square root of 30. And of course, x is greater than 0. So what I want to do now is to test each of these, or test my solutions against these. Now, one thing, let me do to make this a little more distinct is I'm going to write each of my domains out. So I have x is greater than 0, x is greater than the square root of 30, and x is greater than negative square root of 30. So we have 3 domains. Now we need to use a domain such that it covers all of our potential ones. In other words, I don't want to pick one of the, I have to pick one of these domains. I don't want to pick one where it negates the other one. So in other words, I want to pick a domain that works for both of my potential logs. So I don't want to pick a number that works for one log but does not work for a second. The simplest way of that is just, of my 3 numbers here, 0, square root of 30, and negative square root of 30, which one is the biggest? That would be square root of 30. So I'm going to use that as my overall domain. Now, square root of 30 is about 5.47. So finally, looking at my 2 answers here, 6 and negative 5, which of those falls in the appropriate domain? It's only going to be 6. So 6 is my only answer. And we can even check ourselves if we look back. If I put 6 in for x, I'll get log of 36 minus 30, which is of course log of 6, minus log of 6, which definitely is 0. So it checks out. So again, what I did is it brought both of my logs on the same side, solved, and then checked against the domain. Let's see that again. Let's try one more. I'm going to say, question is still going to be solve. So I'm giving a generic question for it on whatever textbook, whatever test you might be looking at it. It could be phrased a different way, but ultimately what you're trying to do is solve the equation. So I'm going to say 2 log base b, of x equals log base b of 4 plus log base b of x minus 1. Now note in this one, there is no value for b. I just gave you the base of b. And the reason is I don't bother giving you a number is because it's not significant. So follow my steps. There's multiple logs here, but what I can do is you might think, well, shouldn't we try to get all the logs on one side? And I could, but if I combine these as they are, now this is where I can use one of my properties, my multiplication property, in reverse. Now the multiplication property, if you don't remember, says if I have log base b of some x plus log base b of some y, as long as they're the same base, I can make it a single log of x times y. So I would do the same thing here. This becomes log base b of 4 times x minus 1. Which I'm going to make log base b. I'm just going to go ahead and distribute that to 4x minus 4. And as you can see, I keep the 4x minus 4 in parentheses. That's very important. And over here, on the left side of my equation, there's 2 in front of the log. That's my power rule, or I'm doing the reverse of the power rule. So that means I'm going to take my number that's in front of the log, I'm going to put it back up here. So if you recall, let me go back up 4. Power rule said that if I have my c, I could bring it down in front, and that's where I get this. So I'm just doing the reverse because that will allow me to use the same property that I did in the first one. So I have log base b of now x to the second. Now that I have a single log on each side, now it's more preferable for me just to use that property where I can just get rid of my logs. I'm left with x squared equals 4x minus 4. Now that I have a quadratic, let me bring everything to one side. I'm going to move my 4x to the other side by subtracting it, my 4 to the other side by adding it. And let me put that in here just so it's clear. So I'm going to put it up here. I subtracted 4x to each side, and I added 4 to each side. Now I moved everything to the left. If you're wondering, well, could you move the x squared to the right? You certainly can. That would make a negative x squared with a positive 4x and a negative 4 equals 0. You can solve that. I generally prefer, when I'm solving a quadratic, to have the squared term, in this case the x squared, to put it on this side, which keeps it positive. For the most part, if I'm going to be factoring or solving, as a personal preference, I find it easier to keep that leading coefficient positive. Now, this one I believe I can factor, so I'll say x, what can multiply to a positive 4 and combine to get a negative 4? Well, it's going to be a negative 2 and a negative 2 equals 0. Using my zero product property, I can set each one equal to 0. At this point, I'm just solving the quadratic equation, and I will solve by subtracting 2, adding 2 here, leave me with x equals negative 2 and x equals positive 2. So I've solved my equation, and that lastly, since it's a log equation, I want to check against the domain. Now you might have been told if you're solving equations in general, you can always check since it is an equation. But in particular with this one, when domains are particular, like with logs, you always want to check against the domain. If you're wondering why you might not have been told to always check against domain. So if you recall, remember what I said is my two logs that that will need to utilize domain are here. Actually, let me change color too. I'm using red too much. I'm going to use green. So right here and right here. Those are the two logs I'm going to focus on. I'm ignoring the other log because it does not have a variable. It's not log of 4x, it's just log of 4. So log base b of 4, whatever b is, it's just some number. So it doesn't really matter. The variable makes it all important. So with my x, by default, it's x is greater than 0. So by extension, x minus 1 is greater than 0. Like before, I'm going to solve. This one's a little more straightforward. By adding 1, I have x is greater than 1. So my two potential domains, and as a rule, we pick the one that is the most restrictive. The easiest way of thinking of that is which number is bigger, 0 or 1? Of course, it's 1, as I'm sure you're all saying. So compare my two answers. Which one of these is in the domain? In other words, which one is bigger than 1? Well, of course, that's only going to be 2. And I didn't circle this one in my very colorful ink. So that my answer would be 2 for this problem. And if you ever wonder, well, what if I forget to do that? What if I didn't check that? Would both of them work? You can try to put -2 in there, and one side would not be equal to the other. And just in general, if you put -2 in for this first log, you would get log of a -2, which is an impossible situation anyway. Simple fact that it's out of the domain means you would stop right there. So as a review, when you have log equations that you can solve with properties of logs, the general way of looking at it is see if you can get all your logs on one side. If you have a constant other than 0 on the other side, that's usually an indication that you would just change from exponential to log form or vice versa and solve from there. In these examples, I had both my logs on one side, but since the other side was equal to 0, by moving my one log to the other side, I can get a situation right here where it's just as easy for me to drop both logs and solve whatever's left. So I hope this video helps you out. Good luck with your future math. Have a good day.